Namaskar, good afternoon everyone. Welcome to the last session of our 5 days faculty development program. Due to the sudden unavailability of a speaker, our first session has been shifted to the afternoon session. Therefore, we will have 2 consecutive sessions in this afternoon. First from 2 to 3 p.m. and after that from 3 p.m. to 5 p.m. After 5 to 5:30. Validatory session, and after 5:30 we will the test, you can say test or you can say anything, whatever we have learned we will just put a mark from 5:30. So without any time delay, let us start. So in this session we have our respected speaker, Professor Debashis. So just a few brief introduction regarding our respected speaker. Dr. Debashis Dey sir is a professor in the Department of Computer Science and Engineering at the Maulana Abul Kalam Azad University of Technology, West Bengal. He received MTech from the University of Calcutta in 2002 and PhD from the Abul University in 2005. He was awarded the prestigious Boys Caste Fellowship by the Department of Science and Technology, Government of India. He received the Endeavour Fellowship Award for 2008-9 by DEST Australia to work at the University of Western Australia. He received the Young Scientist Award in 2005 and in 2011. In 2016, he received the J.C. Bose Research Award from ICTEA, New Delhi. In 2019, he received the Shiksha Ratna Award from the Government of West Bengal. He published more than 400 journals and 200 conference papers in several reputed international journals and conferences. He has authored 20 books and filed 4 patents. He supervised several sponsored projects funded by ICTE, UGC, WBDST, DST, World Bank, AWS, METI, etc. So without any delay, let us listen from Sir. Sir, please.
Hello.
Yes, sir. Yes, sir. You are audible, sir.
Yeah. Good afternoon. So, Pyle, you are there? Pyle? Pyle, please share the screen. And click that hide button, please. Hide button. Yes. Okay. Okay, good afternoon, everyone. I'm just going to start our today's presentation on a very interesting topic called Internet of Music Things, right? So, I just want to ask in this audience, how many of you like music? You can type also. If you like yes, then you can type yes, you like music. Yeah. Siddhartha said everyone like music. Okay. Okay. Let's think that how it works, right? Internet of music, basically, before I go to the music, I just want to mention that what is IoT and how it works. Okay. And IoT is actually combining, rather controlling anything and everything in this world, right? Internet of Things or Internet of Everything, right? So using Raspberry Pi or any other electronic devices with IP, we can control anything and everything in this world. And IoT is basically controlling the whole world. So last week I was in Bangalore, that where we have seen everything, all the consumer electronics products, they are coming up with IoT-enabled system. So IoT-enabled consumer products are coming up in the market in a big way. So if you see the properties of IoT, you will see that First property is connectivity. In order to develop the internet connections, in order to get the connectivity, that is, the internet is the first property. Internet is the most important aspect of our life, and that is a problem, challenge also, that we are not getting good signals in everywhere in this world. Second point is the intelligent. Intelligence means we are talking about intelligent IoT or IoT with intelligence, right? That is called intelligent IoT. Even I told you that we are last 1 week we are in a conference called Age Intelligence, where we are getting everything is transferred to IoT. Most of the products nowadays, starting from your television, to your car, even your washing machine is also intelligent, IoT enabled, intelligent washing machine, or it is now voice enabled using Alexa or Google Siri. We can connect anything in this world. Even the kitchen chimney, that is also IoT enabled. We are using these consumer products using this IoT feature, providing this intelligence in the ground level. Okay. And the third point is the energy. So we have to develop the energy efficient ecosystem, right? So IoT requires very low power. So that is the reason it is more sustainable compared to the existing technologies. And safety, IoT provides the safety features, sensing. IoT has a lot of sensors. We call IoT sensors. And last point is scalable. Scalable means we can add, say, 100 nodes or 1,000 nodes or 10,000 nodes. Using IoT protocol, we can control, say, a light and fan of your house remotely. It can be done for one house, two buildings, or various rooms in your area or any system. It can be scalable, means it can be 1, it can be 1,000, it can be 10,000 also. So that way, actually, IoT can control, right? So scalability is the very important property of IoT. Now, you can see the dynamic nature, that dynamically IoT can handle everything. So what you can see that when you're talking about Internet of Music Things or IoMT, so where we have to use this connectivity, intelligence, energy efficiency, safety, sensing, scale up, everything together. So let's see how IoT is actually helping us in our life to control the operation in a very efficient manner, right? That is the goal of our today's discussion, where we'll be using music. It can be musical instrument, it can be musical performance, it can be music generation, it can be music based, that haptics. So these are the various aspects of IoT where this music can be combined. And just for your information, we have written the world's first music paper combining with IoT. We call it Internet of Music Things. After that, there is one professor called Professor Luca from London School of Music. He has written a paper called Internet of Musical Things. That is the second paper in this world. So these two papers are predominant. It was published in 1819 that time, almost 6-7 years before. Nowadays, if you see that music industry is now also IoT enabled, internet enabled. If you see, the music is not released in CD or DVD format. Music is released in terms of YouTube. And YouTube gets recommendation systems. Everything depends on internet. So they're all connected with internet, and internet gives you the flexibility to connect the whole world. It can connect the singer to the people. It can connect people to the singers, to the that producer, that music players, everyone. So music industry, the business of music industry is huge, because everyone of you mentioned you like music, right? So it is one of the largest industry. So IoT is playing a very important role in this aspect of Internet of Music Things, right? So that is very, very, very interesting aspect that combines music in IoT. So the extra word M is coming in between. So we call it IoMT. Okay. File next slide, please. So already you've seen that Internet of Music things and also the ubiquitous music, they're all combined to form a network musical performance. So what I said that IoMT, which combines the sensing, musical instruments, musical sensors, everything, we are forming it in Internet of Musical things, right? And here also there's a ubiquitous music that combines with IoMT that forms networked music performance. Now let's see what is networked music performance. Okay, next slide, please. So if you see this picture, that the flow shows that you can have a concert, and in the live concert, the artist can join. Some artists can join physically, some artists can join in a online and offline mode. So by that way, actually, we can communicate and perform the musical concert. If you see the left hand side, how this musical instrument is combined to the cloud. Even these instruments also have IoT enabled. They also connected with sensors. They also are connected with Raspberry Pi, and they're connected to the cloud, right? And this cloud is actually through the augmented reality connected to the live concert. Okay, so some of the music players or some of the singers, they can join this musical concert remotely. Okay, so that is a process how these sensor networks, the performance is actually happening together. So first step is to that you have to adapt the environmental knowledge. That means you have to connect to the cloud. Second step is that enhance music performance. That means you can have the best music speakers in your team. He may join remotely, right? So, for example, I can see every one of you joined online. That is remotely you are trying to understand the subject, Internet of Music things, right? So these are the actually features actually which shows mixing of intelligent clouds together, and by that way actually we are getting the concerts, right? So concerts are actually happening to various performances, right? You can see that fourth point is smart music therapy. Music therapy means music is used for meditation, music is used for healing of the patients. Doctors can also remotely, they can give the music therapy to the patients, and remotely they can understand the health parameters, body parameters, right? Body statistics remotely, and accordingly he can control the whole operation, right? And the concert will happen accordingly in the system, right? Actually, this is a total ecosystem how these music instruments, they are not normal guitar. They are connected with IoT guitar. They have the sensors. They are connected with these sensors. So you can connect it with your IoT enabled devices like Raspberry Pi. And by that process, actually, we are connecting the whole data to the cloud format, right? And that is actually purpose of music computation, right? Here. Next slide, please. Suppose, I already have mentioned that the music players can join remotely. Now, you can see this, what is this picture? Can anyone tell what is this person is doing? He's playing a guitar. It's not a normal guitar, okay? It's an electronic guitar which has lot of sensors inbuilt within it, and the sensors are connecting to the whole world, and the person is actually joined a concert, and you can see there is a virtual goggles, right? Means spec, where it's called augmented reality. So wearing that one, the person can, the guitarist can feel that he is within the concert itself, right? He can feel them, you can see the music players, the singers on the stage, as if he can feel he is on the stage. using this IoT. Yes, actually, AR augmented reality with IoT guitar. Yes, correctly, Siddhartha. You have mentioned correctly that this guitar is IoT enabled guitar, and the music player, the guitarist, can feel that he is playing the music within the performance, within the live performance. Maybe 1,000 people inside the room sitting, right? He can feel it. That feeling is very important because that will help him to synchronize their music rhythm, and synchronously he can play with the other co-guitarist. This is the motto for this kind of arrangement, right? Now, why we are doing this? Why we are using this kind of setup? Can anyone say? Anyone? Siddhartha, can you say? Why we are using this feature? Feature. What is the reason that why we are using this IoT enabled systems and goggles together? Right? Yes. Yes.
Virtual establishment of musical world or musical infrastructure.
Actually, by this process, actually, we can show you that to overcome the fear. Okay, correct. He can feel the environment. Feeling the environment is very important, right? He can feel the environment and play the guitar synchronization. If they are playing the different tune or different tone, then synchronization is not happening. Synchronization is very important. Agree or disagree? Synchronization is very important. When someone is playing a guitar remotely, he must sync. Sync means synchronization with the co-guitarist and the co-singers, right? So this is very important. That is the reason we are using this kind of electronic arrangement and virtual presence of that person using the help of augmented reality, right? And that is the beauty of Internet of music things or musical things, right? Two terminologies are very popular. Some people call it Internet of music things, and Luca Provoska, he has written a paper almost next year. So he has written musical things. Both the terminologies are very popular in terms of music performance and music playing, right? So the internet connection, this music, augmented reality, electronic gadgets, they are working together to make the system a very efficient manner, right? Yeah. Okay. Next slide, please. So see, there are two groups, that called ubiquitous group and music haptics. These are the two important area. Ubiquitous means music anywhere, anytime. Ubiquitous, right? Music anywhere, anytime for anyone. Anyone can listen. Now the question is, can the person who cannot listen, can they enjoy music? Right? So if you see that not only we can listen the music from with our ears, if we can make certain kind of body vibration, vibrating haptics, that for the deaf people, those who cannot hear, it's a new way they can understand, feel the music. To feel the music is very important. So it is possible when you connect the electronic device, connecting a jacket or body jacket kind of thing, and you can feel the vibration. When a signal music will come, and your body instruments will vibrate accordingly, right? So these are the very important aspect how we can feel the music, right? Using ubiquitous music and haptics. Clear? So if you see this, yes, next slide. Yeah. So if you see this slide very carefully, this is not a normally ordinary shirt or t-shirt. This is a basically haptic shirt. Haptic means you can wire the system and you can control it remotely, right? Haptic music. Haptic means you have to wearable. It's a wearable haptic. Now, this person who cannot listen properly, any deaf person or physically disabled person, who can physically challenged person who can join this kind of concert using this kind of jacket, and he or she can feel the music through the vibration,
Yes,
not
yes.
by your eardrum, and that is possible using this Internet of Music Things consumer electronics products. So in the consumer range, lot of electronic products are coming up for physically challenged people to understand the bits of music, and that is the novelty of this work, that this jacket is IoT enabled. This jacket, what she is wearing is vibration controlled. It can convert your acoustic signal to a music signal to a vibration, and the person can feel the vibration and enjoy the rhythm of the music through these kind of electronic gadgets. So these are the haptic systems or wearable systems which makes us possible to feel the music in a very efficient and interesting fashion to the audience, right? Okay. Next slide, please. Yeah. Now we are talking about multimodal music. What is that? So how these jackets are prepared? How we are talking about this electronics part and the computational part. It has two parts. One is the electronics hardware part. Second is the software part. For development of this multimodal music, right? If you see the music system, okay. So first, what is that? The singer or the music source, right? And music is segmented, cut into pieces, okay? And that is gone through FFT, first Fourier transform, and there is a haptic equalizer. Within the haptic equalizer, there is a treble and bass. Treble and bass. Those who know music, they can understand the terminology treble and bass. With the haptic equalizer, it actually maps with the vibration of the music, and it can modulate. Modality can be done for the conversion and scaling up. So in the treble and the bass can be controlled, and that can be combined to a mode selection, and which will go to the end product called vibration, right? So we started with a audio signal, and ultimately we got a vibration actuator. So this is actually a consumer electronics product, patented product by some of the leading consumer electronics company. This is the basic architecture of IoT, where actually the segmentation, fast Fourier transform, equalizer, haptic bus. Now by this way, actually, we are making this music possible in a multimodal format, for the people to understand how the system actually works. So it is totally IoT enabled. Those who know Raspberry Pi, or in India also we have Vega processor by CDAC. Okay, so we developed those modules using those the IoT enabled either Vega or by Raspberry Pi, and we can develop this audio signal to an equivalent vibration of the actuator, equivalent vibration. Mind it. Clear? So this is the basic block diagram of a multimodal music generation, right? Where your music system or music rhythm that can be transferred through various electronic segments, and we are getting vibration. And this kind of gadgets are available. This kind of IoT gadgets are available. Electronic gadgets are available as a consumer electronics product.
Yes, yes.
Yeah. Yes, anyone is asking any question? Okay. So these are the actually products actually coming up in a big way for musical therapy also. Based on the patient's need, we can control the audio signal, and subsequently the vibration can be also controlled. Vibration means vibration of the jacket or the instrument or variables, right? That can be also controlled. So we can control the dose just by controlling this treble and bass of the equalizer, right? So based on the patient type, the vibration will be very. So there will be a knob kind of thing which will control the amount of vibration, just like we control the TV switch, sound, audio sound, or similarly we can control the vibration of the body systems, and we can get this kind of very interesting IoMT product. So these products are also started coming up for a couple of years. Now people are not talking about music means one-dimensional music. I mean just listen means one dimension. If you add more dimension, it's become multi-dimensional, right? Or multimodal. And that means you can not only listen the music, you can feel the vibration, you can enjoy with every rhythm of the music. And it's only possible through these consumer electronics products of IoT, right? So we can give the dose to any patient anywhere in the world. Doctors can be remotely joined anywhere. He can understand this, right? And also at the same time, the person is sitting at the room. He can also join the concert. He can also feel the vibration and the actual music as if he will feel, not only the singer, not only the musicians, the other side also, the haptics can take the control and process this operation, right? Haptics are very much used for video games, right? In video games, we are actually using virtual reality. The similar kind of music industry also, we are using similar kind of augmented reality or virtual reality systems, right? So this is the basic operation for multimodal music haptics. Okay. Next slide, please. So can you see this picture? This very interesting picture. These people are wearing haptics, that electronic gadgets. So see various kinds of woofer or gadgets or bass. Okay, whatever the person is playing the guitar, and the body will vibrate. There is a vibrator, right? According to the rhythm. So these are the variables. Generally, when you go to any 3D movie or 4D movie, anyone has gone to any 3D 4D movie? Anyone? If you write, just type what you have seen in a 3D movie, what you have to wear in a 3D movie. Just type what you have to wear. In case of, if you go to any cinema hall to watch a 3D movie, what you have to wear? Yes, someone said 3D glass. Yes. Yes, 3D glass. So when you enter to the cinema hall, right, you'll get a 3D glass, right? And when you return, means when you're going exit, you have to return back the 3D sunglass, right? 3D glass. Yes. So this is very interesting, right? Now, music industries also it is happening, not only for movie. They are, when the people are entering to the any concert, they've been given with gadgets, with different 3D shirts, right? 3D jackets, 3D, that wearable in arm, chest, or in body, based on your size of your shirt, XL, double XL, this kind of electronic shirts are also provided to systems, right? And accordingly, so these are the actually okay. These are the actually processing system for a 3D system, right? So these are the actually various music players are playing this music in a concert, and the music concert becomes very efficiently, very efficiently we can handle this kind of music. And music is, you can feel the music, the participants can feel the music rhythm and the operations, right? Next slide please. So if you see the music, the computational musicology, we have we can divide it into various object-oriented models. Music can be also like, music also has, started with sa re ga ma pa, basic components, so 7 components through which we can have 10 thoughts or ragas, right? 10 ragas are there, which is actually controlling the music operations. And this 10 ragas actually generates thousands of rags, thousands of rags coming out of the music system, right? So next. So inheritance, polymorphism, everything, all the properties, what you have learned in case of object-oriented modeling, music, we have seen everything is possible in case of music, right? We have some research papers also. If you are interested, you can see how we can object-oriented model for the music, and we can do inheritance, polymorphism, all kind of feature mapping in case of music systems, right? This is all possible in music arena. Okay. Next. Next slide, please. Yeah.
Sir, you are not audible. Hello.
Yeah. So this is my friend Luca. See, this is my friend Luca, and he made this several instruments, and all the instruments are connected with sensors. And these are not ordinary music instrument, mind. So these are all very IoT enabled guitar, IoT enabled backpiper. Anyone has seen backpiper? Anyone has seen backpiper? Where it is? Which country the backpiper is used? Anyone can tell? I spent a lot of time in Edinburgh, in Scotland. I was in Scotland 2008. That. So lot of backpipers. Yeah, in England, actually Scotland, these backpipers used to play. And what this Luca is also from London. He has added the Raspberry Pi within the bags, right? Backpiper bag, and the backpiper may be playing the music at Edinburgh, and it can be controlled. He can join a music concert in Calcutta, in West Bengal, right? It is possible. So Luca has shown how this actually music industry is working together, along with the laptops and this controlling of these instruments. Everything is processed very efficiently, right? So we are also developing certain instruments. He is my very good friend, and he's actually from Italy, and some of my students have also joined this group and working together how to convert these music instruments to make it a IoT enabled system, ecosystem, and that is actually happening, right? So this music industry is now totally IoT enabled, and also the drums, music, anyone can join from anywhere. And this IoT makes it possible. Here there is a laptop. He's integrating all the sensors to this laptop using this IoT, right? So that is the beauty, that we can control not only the singers, also the music instruments. Also, we can gather the nature sound. We just put a sensor in a jungle, we can get a jungle sound. We put a sensor near the river area, we can capture the music from there. We can also compose or make a fusion of the music. Music is all about fusion, right? So musical fusion is possible by that process. We can capture and we can arrange this whole ecosystem in a very, that very efficient fashion. Okay, and there is a transaction, IEEE transaction on haptic computing. Those who are interested, they can go through our research papers on haptics, or you can see directly go to the IEEE transaction on haptic computing. Haptic means you have to wear a gloves and you have guitar, and very interesting that you can play the guitar in a remote place, remotely. Even without touching a guitar, you can play the guitar. Is it clear? Or anyone has any question? Without touching this guitar, just wearing a haptic enabled IoT devices, he can play the guitar remotely. So basically, it is a augmented reality. So we do not have to touch the guitar. We can control it remotely and music will be played, or the guitar string will be played. So it is a synchronization between your hand and the guitar, right? Siddhartha, is it clear?
Yes, sir. Yes, sir. Yes, sir.
Sir,
So
I have
Yes.
I want to know one thing, that is IoMT be called a subset of virtual reality?
no, it's one of the part. IoT has very bigger aspect. One of the part is virtual reality. Yes,
We can implement IoMT using virtual reality.
yes, you're right, Siddhartha. Yes. Okay. So even the person do not have to touch the instrument. He can remotely play the guitar. Guitar maybe 10 feet distance, maybe 100 feet distance. Maybe from I'm in Calcutta. I can control the guitar at Mumbai also. It is also possible, right? So this is also possible to do this operation like this, right? So these are the actually various interesting aspects of haptic computing, and these operations are, we are in the process. We are all working in this haptics. Anyone is interested? Those who are interested, they can work with us. No problem. We use this haptic. We develop these haptic instruments. Little bit instrumentation, and instrumentation maybe 50% electronics part and instrumentation part, and 50% is programming. How we can control the operation of this string using your hand-eye coordination. So haptic computing is becoming a very, very popular for music industry, right? Okay. Next slide, please. So this slide shows actually various components, that how we can group this music. It means music communication, right? Music communication in a group or individuals, right? And compute and create a authorship of the music, and we can frame the computational music with various compositions, reconstruction, and reorientation, right? Okay, thank you. Next. So musicology, musicology is very, very important, that we have to identify, we have to convince, we have to make the research, innovation, so many things, music creation, transmission, and enhancement. Music first is creation, then transmission and enhancement. So these are the various aspects of musicology. Okay, next. So already I have mentioned these things: music technology, IoT, human-computer interface, and machine learning, right? Especially edge intelligence is very important. So these are the very important aspect. Okay. Yeah, it's totally machine learning based. Those who have asked the question, totally machine learning enabled, IoT enabled, or ML enabled systems, because we are using edge devices and edge AI, intelligence at the edge. That is the technology for today, and we have developed those edge AI. Yesterday I was in Bangalore. We have seen that this the VLSAD conference, the people have developed those musical dongles and systems and everything for music operations, right? Everything is there. Totally, it is AI enabled, right? Okay, next. Now there are various research areas, right? Domains that either opportunistic music or entropy ambience, crowd sensing, contextual music. So many areas are there. People are working in this domain. Okay, next. Yeah, if you see the next slide, yeah. Yeah. If you see that there's the 4 layers: physical layer, then second layer is edge layer. Physical layer means the sensors. Second layer is the edge layer. Third layer is the cloud and the user application. So these are the 4 basic parts of music computation, right? Actually, this is the way actually music systems operations are happening together. Okay, next. So this is a workflow, how the sound is generated and how the system's operations are happening. Already I have explained it. Can you please share the presentation? Yeah, I can share the presentation. You can simply mail me. I will give you the slide. Okay. So these are the total operations, actually workflow, how these music systems happens, and it's self-explanatory that how the data flows from preparation of cloud, resource management, cloud-based edge resource management, and how this controlling operations is happening. It's very simple and self-explanatory, right? Next. These are some calculations I'm not going in today, timing calculation. Next. This is used for synchronization. You know, timing is very important. So time synchronization is very important to important to control the whole operations in the same fashion, synchronized fashion. Without synchronization, music is lost. So timing energy is very important to maintain. Next. We did a lot of calculations for power analysis and music power analysis. Next. Now this ambience intelligence, the term is ambience intelligence, right? Means the environment, music needs the environment where the guitar, sitar, you know that already I mentioned that this 3D music, 2D music or 4D music or the music for the different drum, we are creating the ambience. We have to reduce the delay or latency, the edge computing and efficiency can be improved, okay? So by this process actually, we can handle this music operations very efficiently. And we have heard about fusion, we call information fusion, which is very important for musical operations, right? By this way, actually, we handle the whole operations. Okay, next. So see, there is a physical layer already I mentioned where we have all the electronic gadgets, acoustic sensors, you know, the guitars with haptics, and ultimately processed in the edges, tablet, laptop, or desktop. Okay, so these are the 3 layers: the IoT layer, you know, the edge layer, and the physical layer, right? Next. Okay. Happening together in a synchronized fashion. Okay. Next. Next. We also measured the entropy in a whole system entropy. Next. Entropy is the measure of disorderness. By that way, we have to calculate the efficiency of the music, and so many parameters can be tuned in an IoT environment. Next. Now, due music is very important. That we have published one paper called due music. I just like to mention that internet is, you know, is the problem, right? Internet is scarce, right, in various places. So if you using this due music, where if your internet connection is less, then we have to use the cache memory of the device. If your cache is high, cache memory means every mobile phone or any electronic device has cache memory or cache memory, whatever you say. If the cache memory of the device is high, we can hold the data for a longer period of time. That is called due music. Sometimes you have seen the buffering on the internet, right? YouTube. That is called due computing. Buffering can be reduced if your cache memory is high. So this is known as due music. So what we have developed this model that if the internet connection is unstable, still you can listen the music very efficiently. That is called due music, right? We have written one book also called Due Computing, right? Next. So these are the various pyramids that how this actually data center works. More or less, I have covered that what is actually IoMT and how it operates, how the system works together very efficiently and very interesting fashion, so that the systems can work together in a very synchronized fashion. Right. Next. Now this is the picture of Dew Music, which shows that how we can hold the data for efficient fashion. Next slide, please. And these are the workflows of Dew Music. I'm not going in detail. It will take. I'll share the slides. If you face any problem, you can mail me and we can discuss how this actually operations happens. Next. Next. Pal, can you go to the last slides? That. Yeah. So I think it is clear to you how this actually ecosystem works. And if you see this conclusion that music is very important in our life, and computational music is very important because computer can understand the music, and also we can connect the musicians, guitarists using AI-enabled systems, and using this programmable logic, we can connect the music players, synthesizers, guitars. A lot of music theories coming up, and especially the consumer electronics. So consumer electronics products are coming up for music generations and music operation. Okay. So these are the future scopes that Dew Music or humanized computing music or ICTEA. Nowadays music is coming in generative AI, large language model, right? NLP. Even Kishore Kumar is not here, but we can generate the music like Kishore Kumar and play it remotely, right? It is happening, right? Kishore, if you can mimic the voice and connect it with the internet, and these things are actually happening with the help of this ChatGPT and generative AI. So these are the various important factors for future music industries, especially for the IoMT. Okay, thank you. Next slide, please. These are some of our research works. Those who are interested, they can download these papers. We have around 30-40 papers, which is on music industry and IoMT, how it operates. And for your information, we are about to publish a paper this year, not paper, book on internet music things. Hope you'll maybe we'll share it to you, Siddharth, and to the participants. Okay, thank you. Any question or any question or comments?
Any question? If there is, dear respected participants, if you have any question, kindly put it into the streaming, YouTube streaming chat box or Meet chat box. Okay, sir. Till now, no question. Just I have a very basic, very basic question. Sir, what is your observation on this point? That technology, any invention which is which can change the lifestyle of human being. Social revolution, just like Amazon, Flipkart, e-market, or Ola, Uber, or in fact, a smartphone from feature phone. So this kind of innovation, implementation of science and technology, it should be preferable, or more and more fine-grained development and application of science and technologies like
both are important. Both are important.
Yes,
And especially this IoMT has, in terms of IoMT, I can tell you it is a lot of applications for brain health, especially health balancing, right? Especially for disabled person, also for that there is something called Maha Mrityunjay Mantra.
yes.
If you give proper dose, some people can also synchronize with your body, and with the resonance, it can recover your patient.
Yes, sir. Yes, sir.
IoMT major application is in therapy, music therapy.
Yes, sir.
Okay,
Yes, sir.
so a lot of music therapy is happening with the help of this Internet of Music things, and that is playing a major area for our music industries and all this IoT. Okay.
Yes, sir. Sir, and another question in the meet chat, Dr. Sanjeev Kumar Das. Any use of machine learning in this area?
So I told you already, it is totally machine learning based.
Yes, yes.
Totally machine learning. If you see the applications like called deep learning techniques or explainable AI, these are the two important areas this music industry is actually happening. Work. Okay.
Okay. So
Deep learning is very much used. Transfer learning is used for various operations. Yes.
So is there any question from participant side, or we will come to the conclusion?
Okay.
Okay, sir. Thank
So
you.
any
Thank you.
question? My mail ID is there.
Yes, sir. Yes.
Any question? You can anytime you can send me WhatsApp or mail. No problem.
Yes. Sure.
Okay. Thank you.
Sir, sir, as a guest of honor, sir, we will show one. We will display one certificate on the screen. We will
Okay.
be happy
Thank
if
you.
you kindly accept it.
Okay. Thank you. Thank you.
Please, sir, just display the certificate. Sir. As a guest of honor, we are presenting the certificate.
Okay. Thank you very much.
Okay, sir.
Okay,
Thank
okay.
you.
Thank you.
Thank you very
Thank you.
much.
Thank you, sir. Thank you, sir. Thank you, sir.
Thank you.
Yeah. Thank you. Okay. Thank you. Thank you very much. Okay. Thank you. Thank you. Anyone? Any question? You can mail me. Feel free to mail. Or if you're interested to see our pics, we can show you. Very okay.
Very interesting topic, sir. Thank you very much.
Yeah, if you work, it will be more interesting. And lot of electronics is involved. Lot of computational is involved, right? You can. If anyone is interested in machine learning for IoMT, you can contact me, or you can contact Siddharth also. Siddharth is my very good student, and I'm proud of Siddharth. Yeah.
Thank you, sir. Thank you very much, sir.
Thank you, Payal, for taking the pen, for sharing the screen. Thank you. Thank you, everyone, for joining my session. Lipika madam is clear, na? We have asked the question. Okay. Thank you.
Yeah, thank you, sir.
Okay, sir.
Okay, we'll start the session now. Welcome you all to the last session of the 5-day faculty development program. In this last session, we have Dr. Padmalochan Bera with us. Now, a brief introduction about Dr. Bera. Dr. Padmalochan Bera, an associate professor of computer science and engineering in School of Electrical Sciences, IIT Bhubaneswar. He has completed PhD in Computer Science and Engineering from IIT Kharagpur in 2011. He had worked as a postdoctoral research fellow at University of North Carolina, USA. Before joining IIT Bhubaneswar, Dr. Bera worked as a researcher at General Motor Research Lab and senior scientist at Infosys Lab. The major area of his research is networks and cyber physical system security. Dr. Bera lead network security research group in IIT Bhubaneswar consisting of 20 undergraduate, 10 postgraduate and 6 doctoral students and project staffs. Dr. Bera has a number of project funding from government agencies like DRDO, CPRI, and ministries Bharat Electronics, Cisco, and all. He has published more than 70 research papers in reputed journals and conferences. Dr. Bera has research collaboration with various international institutes such as University of North Carolina, Mellon University, University of Missouri, Oxford University, and Florida International University. So now we request Dr. Bera to start the session.
Okay, I thank the organizers of this FDP and Professor Mishra for inviting me for this talk. I welcome all the participants. Let me share my screen. Just a second. Can you see the slides?
Yes, sir.
Yes, yes.
Okay, so now tell me, I am changing my slides. Can you see the changes in the slides?
Yes,
Yes,
yes, it
yes.
is
Yes, sir. Yes,
changing.
sir.
All right, perfect. So, good afternoon, all. I will be talking about AI for network security, an intelligent intrusion detection system perspective. So, this is the title of the talk. So essentially, I'll be discussing about the security challenges we are facing today, especially in ICT information and communication technology era. So, what are the different security challenges and how AI comes into the picture to solve some of the security problems. Okay, so in that directions, I will be discussing about some existing network attacks, then what is intrusion detection system, how ML is related to intrusion detections, and then one of our research where we used reinforcement learning in intrusion detection system. Okay, so this is the outline of my session. If you see the applications, services which we are using today, so they are heavily dependent on internet-based computing and communication, starting from healthcare, starting from energy uses like utility services, banking, various application services which are heavily dependent on internet-based computing. Then if you see that cyber physical systems which also we deal with in different stages, they are also we see significant amount of in data that is getting generated across these cyber physical systems, which are either stored in some cloud platforms or remote servers, or these data which are generated, they can be transmitted from one place to another place, and then various analysis is performed on those data for different decision making, right? So the data, large volume of data getting generated, which are stored in cloud server or which are transferred, and then based on those data, various decision making, various analysis is performed, and then based on these analysis results, some control actions are taken, some decisions are taken, right? So if you talk about smart grid advanced metering infrastructure, there smart meters are installed in houses, which basically collects energy uses data. So you are using your different electronic devices in your home, in your houses, So all the electronic devices consume electricity. So those energy uses data are basically collected by smart meter, and those are transferred through wireless to the back office like energy service provider office, and there basically that is a server, and there a lot of analysis can be done for billing, for different types of control actions, like in a particular home there is surge in electricity, so how that can be controlled, or there is some malfunction happen in a particular area, so that can be also controlled based on the data that is received by the server accordingly, right? So this is one application. Similarly, industrial control systems, there are sensors which basically collects the data of surroundings. It may be related to weather, it may be related to various production informations. So those data are basically collected, and informations are again communicated to a particular server through a network, and then analysis is performed. Similarly, if you look at healthcare today, large amount of healthcare data which are basically used for different types of analytics, for different diagnostics, and that is also related to telemedicine services. So in all these cases, you can clearly see that information communication technology, so they are very much related, and as the communication channel through which the data is transferred or the data is stored, so that communication channel is not a secure communication channel. So obviously there is a challenge that the data might be modified, data might be lost. Sometimes unauthorized users, they may access the data, and that may lead to malfunctioning of the system, right? So if we see the overall security footprint in today's applications, we broadly classify it into three categories. One is in computing platform, what are the security violations? Second one in network infrastructure, and third one is administration and planning. So in computing platform, mostly the attackers try to access the active memory pages when a program is running, or program execution path, or operating system control access control rules. So those entities are basically accessed, and in the process the sensitive informations are either modified or disclosed. Okay, so this is a problem, and this
अपना
also
नीचे
leads
बहुत
to
बड़ा करंट लेना होगा तो मतलब वोल्टेज बहुत
वोल्टेज
ज्यादा
इंक्रीज करना होगा
कितना पहले इंक्रीज किया था कितने वोल्ट
yeah, this also leads to quality of service degradation. Then second platform is network infrastructure. So in network infrastructure, you can see multiple nodes, they are interconnected, through which the data is transmitted from one end to another end, right? So there the network devices like routers and switches, if they are misconfigured, then that may lead to different types of attacks in the network, right? So when I say that device level misconfigurations, so it is related to the network devices mainly. So for example, you have enterprise network, where suppose a guideline is that from node A, remote services, okay, remote access, remote terminal service is permitted to node B, or let's say telnet service is permitted to node B, from node A to node B. So if this is to be configured in the network router, so then appropriate, you have to open the terminal, and then you have to configure the IP address, that okay, node A's IP address and node B's IP address, and then the network service is SSH or telnet, that needs to be permitted, right, from node A to node B. So that basically allows the corresponding traffic, network traffic. Similarly, if I say that from node A to web server, so the internet service has to be basically blocked. So there should not be any internet accessibility from node A through web service or web server, right? So if that is to be blocked, then obviously similarly in a particular router, the corresponding access control tool can be configured. But then it is also nothing is mentioned about how the traffic will go from node B to the web server. So therefore, if you do not configure these rules properly, then what will happen? There can be hidden tunnels that can allow the attacker to uh, bypass the access control mechanism, and in the process create attack paths, hidden attack paths. For example, in this particular scenario, node A can do remote access, remote terminal access to node B, and from there it can go to the internet, it can access the web server. Though it is not permitted, it is given that node A cannot cannot access internet. However, node A can go to the node B through remote terminal application or telnet application, and then from there it can access the internet, right? So therefore you can clearly see that, and it is in this particular case we have only two nodes, but in normal scenario, in enterprise scenario, there are thousands of such nodes, and your application policies are very complex, network service dependent. So in such case, if you just open a single router terminal and configure it, then that will definitely may introduce certain loopholes, right? And in the process, attacker can exploit it and launch various forms of attack. Okay, so the attacks in this particular scenario can be either denial of service, hijacking of server, network jamming, hidden tunnels, various forms of attacks that may happen because of device level misconfiguration. So therefore, ideal scenario is that you need to consider the whole network as a single entity. Okay, so distributed implementation of the rules in different routers. There may be thousands of routers. In all those routers, the rules which are configured, that needs to be configured consistently. Otherwise there will be uh, 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 loopholes which can be exploited by the attackers. And it has been reported in recent report, 2020 report by NIST, National Institute of Standards and Technology. It says that 65% of the cyber attacks today, they are basically due to device level misconfiguration, your network device misconfiguration. So this is a serious challenge, so which needs to be looked at, and therefore we need to come up with appropriate solutions to identify such type of attacks, as well as defend those, right? And then the third one is administration and planning. So these days, when we design web pages, right? Through web pages, users, they basically access a particular service. They basically log into a particular portal, and then from their various service they access. So these web pages or these web services, they are basically implemented using different web technologies, right? Like ASP.NET, PHP, various type of web technologies are used. But if those are not upgraded, those are not patched properly, those softwares are not upgraded or patched properly, so that may also create loopholes, that may also open paths for the attacker to get access to the resources, and launch various forms of attack, right? So these are the three different platform, or you can say that infrastructure, how where basically cyber security violations that can happen, and we need to come up with good efficient solutions to handle this. Okay, so this is a generic you know network architecture, where you can see that this is one enterprise network uh, area network, and this is the another network. Now from outside network, attacker may send traffic to one of the node in this particular network by exploiting the vulnerability in this node, and in the process the whole network can be compromised by the attacker machine, right? So in this particular case, obviously the attacker is outside of the enterprise network, but it may so happen that the attacker may stay inside the enterprise network. So the intrusions may happen internally as well, or it may happen externally, right? So we need to catch all such problems. So therefore, considering all different forms of network violations or security violations, so we define all different attacks into a common terminology, by a common terminology that is called intrusion. So what do we mean by intrusion? Intrusion is attempts to compromise the confidentiality, integrity, and availability of a system or a network, right? So obviously CIA, confidentiality, integrity, and availability. This is the three common uh, services. Okay, in three common network security services which needs to be enforced when you come up with any security solutions. So confidentiality is very straightforward, that whenever data is accessed, it has to be accessed by authorized entity. Okay, and integrity is when data is in transit from one node to another node, it should not be modified. If it is at X, then it should remain X till its lifetime, right? Similarly, availability is like when a particular services, network services are provided, supported to different users, then these users should able to access it uh, 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 from its system without any violations, right? So it may happen that attackers may consume the resources of the server largely, so that the legitimate users, they may not able to access the service. So that should not happen. So any such attempt to compromise this confidentiality, integrity, and availability is called as intrusion. And intrusions can be external intrusions, it can be internal intrusions. Obviously, external intrusions, it is easy to protect, easy to identify, because I mean, we know the external IP addresses. So based on the IP addresses, we can define certain rules, and then those rules can actually filter the packets from external IP address, right? However, internal intrusions, that is a little tricky, because in case of internal intrusions, at least some authorized, I mean, users, they have some authorized access to the system, but user try to misuse their access privilege and try to gain attempt further additional privilege, and then that will allow the attackers to launch various forms of attack. So basically, like you have user access, then you are gaining root privileges, right? Similar kind of. So you have certain access, but you are misusing this access privilege to gain further privileges, and that can be exploited by the attacker. So this is a little tricky to identify internal intrusion, but external intrusions also needs to be identified, and pretty good solutions are available for internal external intrusion. Okay, so if you see that the traditional network intrusions, mostly these are the types like denial of service, distributed denial of service, man in the middle, IP spoofing, port scanning, many such traditional network intrusions are there. And then system intrusions are basically targeting to a particular computer, not the whole network, targeting a particular computer, and try to get informations, sensitive informations, or get access to the sensitive data in an unauthorized manner, right? So there are system level intrusions like worms, viruses, adwares, ransomware, etc., malwares, and network level intrusions are these. If we see denial of service attack, the basic idea of denial of service attack is that the attacker, they try to consume the resources, okay, of the server, like CPU, main memory, storage space. So from a spoofed IP address, large number of attack packets, large number of let's say service requests may go to the server. In the process, server's buffer would be completely exhausted. In the process, the legitimate users, they may not able to establish connection with the server. So this is the general form of denial of service attack, but there are many variants of that. So I'll not discuss much of details today in this. Distributed denial of service, here basically multiple nodes, I mean attacker basically take control of multiple nodes, and from these multiple nodes we call them as bots, and these bots together try to flood the server. Okay, so that is called distributed denial of service. So many such attacks have been seen in that form. Then you have man in the middle attack. So in the man in the middle attack, basically when the session communication session is going on between client and server, so that can be hijacked, that can be basically broken by a third party, right? So let's say TCP communication is going on between client and server, and the sequence number that can be maliciously communicated to the server, and in the process server will feel that the intermediate node, that is the legitimate client, and in the process the session between the client and server can be listened by the third party. So this is something also possible, even if the communication is done through some cryptographic protocol, that can be also broken by the third party. Okay, so then you have port scanning attack, where basically the attacker gain access to a particular system, and then it scans all the open ports, the ports which are open. So that can be identified. In the process, it can it will understand that what are the different software applications which are running in the computer, right? Because we know that network applications are traditional standard network applications, they are actually binded with port numbers, right? For example, telnet is binded with 23, mm, uh, http service is binded with 8080. So these port numbers, by scanning the ports, attacker may able to identify that what are the applications which are currently running in the computer, and in the process they try to compromise those applications, exploit the vulnerabilities of those softwares, and gain access to the machine, and steal sensitive information, or modify sensitive information, right? So this is called port scanning attack. And then you have phishing. So here this is similar to administration and planning, where basically a lot of web technologies are used for designing web pages. So attacker basically creates similar web pages, and then that can be used to uh, uh, used to make the legitimate users understand that this is a valid page, and in the process the users, they may provide their login credentials or sensitive informations, and that can be actually used by the attacker for gaining control, right? So this is also another form of attack like malware, which is malicious softwares. So that can also lead to various security violations at the host level as well as in the network level, right? So overall, if we see, there are many such forms of intrusions, and in fact, there are a lot of intrusions whose signatures are randomly, dynamically changing. It's not known that the signature of those attack patterns are clearly not understood. So the attack patterns are changes. So in the process, it is very extremely difficult to identify that whether a particular packet or a particular node is a intrusive packet or it is a malicious node, right? So if we look at the solutions for identifying intrusions or preventing intrusions, so mainly there are three classes: firewall, intrusion detection system, intrusion prevention system, and then you have completely different directions, that is cryptography. Another solution, that is cryptography, which is a completely different directions. So firewall essentially filters the network traffic based on IP addresses, port numbers. So it looks at the packet header, okay, incoming packet header from outside network, and then it basically checks that whether it basically there is a database of blacklisted IP address or certain rules are there. Based on that, basically it filters the packet. Okay, so therefore it is rule driven. Firewall works on based on certain rules, and then that basically looks into the packet header. On the other hand, intrusion detection system, it basically filters traffic based on payload as well as packet header. So it looks into the payload of the packet. So if there is any malicious message or data that is being transmitted inside through the packet, so that could be also identified. But obviously, like identifying the large, large within the large payload, identifying malicious string or malicious information where the signature changes dynamically, it's not so easy, right? So this is intrusion detection system, and in intrusion prevention system, there essentially you detect the intrusion as well as you stop those, okay, prevent those intrusions. So extra effort is required in this case. And other than that, cryptography, basically there you encrypt the data, upload it into the cloud, and then when user they try to access it, obviously their attributes will be verified, their key will be verified to provide the necessary access to the corresponding user. The same time, like it may happen that in today's machine learning applications, you see that many nodes, they basically train the data, train the model using various data sets, and then whatever the results that is generated, those results are basically sent to the server, which may be a cloud server, and then cloud server basically performs various computations on the received data from multiple agents, and then it send back those values, maybe we called it as rewards. Those values are sent back to the agents, and then agent can change their model parameters, training model parameters, till the machine learning model converges, right? Training process converges. Right? In this case, you can clearly see that the data can be encrypted, data can be actually uploaded to the server, and then computations can be performed on the encrypted data. So there you do not have to decrypt the data, rather you can perform on the encrypted encoded data, perform computations. It can be average computation, addition, whatever statistical computations the machine learning model does. So that can be computed on the encrypted data, and then the result can be communicated back to the agents, and then agents can decrypt it. So therefore, heavy computations can be actually offloaded to the cloud server, and there on encrypted data itself, the computations can be performed. So those sort of solutions has evolved, but obviously one of the major challenge of cryptographic solution is computational overhead. So good amount of computation time is required for encryption and decryption and performing computation. So that is where basically for real-time applications, sometimes it is not feasible. That's why people go for solutions where basically we use firewall and intrusion detection system together. Okay, or these days also there are lightweight cryptographic protocols which are coming in, so that can be also used as a solutions to identify and prevent intrusion. Right. So if we see that what is an intrusion detection system, my focus in today's talk will be on intrusion detection system. Okay. So what is an intrusion detection system? Intrusion detection system monitors the network traffic and tries to identify if any malicious activities in the network happens due to based on this malicious by identifying this malicious traffic. Okay. So this is the basic idea of intrusion detection system. And if we see the features or requirements of any intrusion detection system, it should be executing continuously with minimal human intervention. So the software should be completely automated. So like network administrator role will be less, and it should run continuously into the system, and it should be fault tolerant. If one node fails, right? So suppose n number of nodes are there in which you have implemented the intrusion detection system as in a distributed manner. So if a particular node fails, still it will able to function, right? And resist subversioning, if any upgradation happens in the intrusion detection system software, so still it will able to function. And minimal overhead on the system, computing overhead should be less. It should be scalable to serve large number of users, like uh, uh, large scale networks. It should able to identify the intrusions and allow the legitimate traffics, and allow dynamic reconfigurations, because the policies, the attack signatures, those basically changes day by day. So therefore the intrusion detection system should be dynamically reconfigurable, right, based on the new attack signatures. So if we see the architecture, how the IDA software looks like, it consists of three components. One is agent. Agent is basically like sensors. It gathers informations from different part of the network, and send it to the analyzer. So agent is just like at different routers, it collects the packets which are coming from different nodes, right? So it's like sensors which collect the data packets and send it to the analyzer software, so which will basically analyze the data based on certain rules. So agent is the sensors. The next part is analyzer. It analyzes the received data from agents and based on certain rules. Okay, and identify that whether this is malicious data, or this is legitimate data. Okay, and then notifier, this is the basically actuator which basically informs that, okay, so this is a control actions that needs to be taken, right? So therefore agent, analyzer, and notifier, these three components, software components, comprise it basically defines the intrusion detection, right? So if we see the types of intrusion detection system, based on the detection model, that what is the logic you are applying uh, uh, for this analysis, for this analyzer, based on that intrusion detection system can be classified into signature based versus anomaly based. In case of signature based, I'll go to that. So in case of signature based, basically you have a database of signatures. You have a database of signatures, attack signatures, and then whenever a attack pattern, attack packet comes in, so you check the payload of this attack packet whether it is matching to the signature database. Okay, it's just a pattern matching, and based on that it identifies whether it is attack packet or legitimate packet. On the other hand, in the anomaly based intrusion detection system, so there basically we record the behavior of the network nodes for a period of time, all the packets which are flowing through the network from different nodes that have been observed for a quite long period of time, and then we use some thresholding mechanism or behavioral analysis mechanism to identify that if there is any anomalous behavior, right? So here we do not really use any database of signatures, rather analysis is done by on the data which is flowing through the network for quite long period of time, right? So this is the type of intrusion detection system based on detection model. Then based on monitoring environment, application environment, you can classify it into host based versus network based. In case of host based, target is only one computer system, and in case of network based, target is the whole network. It's systems of systems, okay? And then operation wise, it can be offline intrusion detection system or real time. Offline intrusion detection system, like you collect all the data which has flown through the network, and then you take all this data, push it into a server, disconnect the network. Now you run your software, intrusion detection system software, on those data to identify that this is wrong and this is right. Okay, this is malicious and this is legitimate, right? This is offline. And real time means online data when it is coming into the network. So then and then you basically decide that whether it is legitimate or attack packets, right? So operation wise, it can be offline or it can be real time. And then architecture wise, it can be centralized. The whole and software, the IDS software, can be running into a centralized server, or it can be running into multiple nodes in a distributed manner. Okay, so these are the different types of intrusion detection system depending on application environment, type of logic which are used in the software monitoring environment, and so on, right? So signature based IDS, as I mentioned, let me give you some examples. So for example, you have uh, uh, a corporate LAN here, okay, and some from the internet, some packet is flowing to the corporate LAN, right? Let's say it is an HTTP packet, and in the HTTP request packet, you know, you have header and payload. So in the header there are IP addresses, port numbers. Your firewall basically could not able to detect, because firewall passes the corresponding packet. It sees that okay, all the IP addresses and port number, those are not blacklisted, so therefore based on this rule it may pass the corresponding packet. And then when it goes to the IDS, what IDS does, IDS basically checks the packet payload. And it has been seen that you can see that there is in the payload, there is a string called surprise. There is a string called surprise, and then the IDS basically matches the signature database. And in the signature database, you have surprise string. So therefore, as it is present in the payload, so therefore this packet is a potential candidate for intrusion detection, potential candidate for intrusion. Okay, so you may have large signature database, so that large signature database needs to be matched here. But it is a it is a static process. Like if the signature is not known, or the signature is not available in the database, then the attacker can bypass your intrusion detection. Okay. So for example, here you can see the header is IPv4, protocol is HTTP, destination port number is 80, and the signature string is surprise, and that basically makes the corresponding packet detected as intrusion. So this is signature based. So obviously the problem of signature based IDS is that zero-day attack or unknown attacks, where the signature of the attack is changing, which is happening these days. You don't know that what is the attack signature, right? So zero-day attacks cannot be identified by signature based IDS. And obviously if there are changes in the signatures, that is not suitable for signature based IDs. On the other hand, positive side is that it definitely provides high accuracy. High accuracy in the sense because it is just doing pattern matching, database pattern matching. So only let's say set of rules are there, and you are just verifying with that. So if it will definitely give you high accuracy, like a particular packet having a signature which is one of the attack signature, then accurately it will able to identify. And low false positive rate, like legitimate packet, a good packet that will not be false classified as intrusion packet. So false positive rates will be also low in case of signature based IDS. But the major challenge in today's world, what we are facing is unknown attacks. Lot of attacks whose signatures are completely unknown, and therefore signature based IDS cannot be applicable. So then we go for anomaly based IDS. Look at, in case of anomaly based IDS, as I mentioned, that there is a behavioral analysis or threshold analysis that is basically performed. For example, you can see here. So again, firewall passes all the incoming packets. Then when it comes to the IDS, so IDS, what it does, it basically observe the incoming TCP packet, UDP packet, ICMP packet for quite long period of time, and based on the observations, it basically came up with a baseline that TCP packets size is 100 bytes per second, UDP packets flowing through is 112 bytes per second, ICMP packets is 43 bytes per second, let's say. So this is based on the periodic analysis, and then suddenly one UDP packet comes in which is 425 bytes per second, then immediately it can be captured as an intrusion packet, right? So therefore, in case of anomaly based IDS, we really do not have any signature database. Rather, we do historical analysis, like profile analysis, and based on that we see that whether a particular behavior is normal or abnormal. For example, you are driving with a speed of 60 km per hour, and then suddenly after some point you are driving at 120 kilometers per hour, right? So obviously there is something wrong. So those can be identified by observing the behavior for quite long time, right? That is where anomaly based IDS is actually good, because it can be trained. It can be trained with good data sets, right? Dynamic data sets, it can be trained, and in the process you can do better and better identification of the malicious packets, right? So if we see that threshold detection and profile based, these are the two main techniques which are used under anomaly based. In case of threshold detections, you basically based on the behavioral analysis, you based on basically the periodic event analysis, it checks that whether a particular event is happening more than the threshold or not, excessive time a particular event is happening or not, and that is basically, if there's something which is beyond the threshold, that would be detected as a anomalous behavior. In case of profile based, it characterize past behavior of users and group, and then detect if there is a significant deviation from its normal behavior. Okay, so these are the two techniques which are used in anomaly based. Obvious advantage of anomaly based IDS is zero-day attack detection. So most new attacks, novel attacks, that can be identified with good accuracy and less false positive rates, using anomaly based IDS. But if you do not use appropriate intelligence, then obviously the false positive rates can be high as well, right? For example, your anomaly based IDS, your behavioral analysis is so strict, so restricted, that sometimes your legitimate packet also can be treated as a malicious. Okay, so that to stop that, you need to introduce some intelligence into the intrusion detection system software. So there basically machine learning comes into the picture. I'll go to that slowly. So positive thing is that zero-day attack detection, and obviously these high false positive rates and slowness, like time complexity, those needs to be taken into consideration, right? So if you see the performance matrices of IDS, intrusion detection system, normally these are the parameters which are there: true positive, false positive, true negative, false negative. True negative means intrusions that are successfully detected by your software, IDS software. Okay, and false positive means normal or non-intrusive packets that is wrongly classified as intrusive packet by the IDS. True negatives, normal or non-intrusive behavior that is successfully labeled as normal or non-intrusive is true negative. False negative intrusions that are missed by completely missed by the IDS and classified as normal or non-intrusive. So these are the parameter. Based on these, we basically calculate accuracy and false positive rates. So accuracy is calculated as number of true positive plus number of true negative divided by all sum of these. On the other hand, false positive rate is number of false positive divided by true negative plus false positive. So if we see, if you compare it for good intrusion detection system, we require high accuracy and less false positive rates, low false positive rate. So this is the measure for good intrusion detection system. Accuracy should be very high and false positive rate should be very low, right? So that is what our objective is. Now, the data sets which are used for intrusion detection system training, there are many data sets available, but these are most widely used data sets. NSL KDD, it is a pretty old data set, right? It has informations about various types of attacks like DOS attacks, probe attacks, UTR, R2L, different types of attack as well as normal packets. So around 1,25,973 records are used for training and 22,544 records are used for testing here, right? In NSL KDD data set. Yeah, I am in a lecture actually, online session. Yeah. So if you see the training NSL KDD dataset, so this is a old dataset, but it has large number of records of specific attack categories, like which is common: denial of service, probe, UTR, R2L, to these categories. And then you have UNSW NB15. This is a recent data set. Here you see that attack types are further enhanced, like not only these 4 types of attack, rather you have records of different other attack types as well. Okay, so this data set is like published in 2015. So this data set can be also used for training your you know intrusion detection system software. And then you have AWID CLSR dataset. So this is also 2015 published dataset. There you have different types of attacks like flooding, impersonation, injection, right? And this is more Wi-Fi specific, Wi-Fi network attacks specific dataset. Okay, so these datasets are actually used for training the machine learning, training your machine learning models for intrusion detection system. And the description of these data sets are also available, like for NSL KDD data set you have DOS, probe, UTR, R2L, all these attacks and their subclasses. All the subclasses, Java subclasses, all are available here, like teardrop, UDP, storm, Apache 2, worm. So these are very prominent subclasses. Then you have here UTR, you have buffer overflow, fault, rootkit. So all the subclasses of different forms of attacks, those are available. These features will be actually used for classifications when you use it for training of the machine learning models for intrusion detection. Similarly, for UNSW NB15 also you have different attack types, right? And then their attack description is available. AWID also you have different types of attacks and their subclasses. Yeah. So therefore now we have seen that there is a large types of there is a potential possibility of different cyber attacks across multiple domains. It can be utility, it can be energy, right? It can be healthcare, it can be industrial control, in banking, many applications today. There is a potential possibility of cyber attacks of different form. So how to protect our devices, how to protect our network? So if we see the solution, so normally the solutions are integrated solutions today. You have firewall as well as intrusion detection system. These two together can be used as a integrated solutions for cyber defense. Okay. So for example, in Rashtrapati Bhavan, when you are entering into the Rashtrapati Bhavan premises, at the main gate, so there are security personnels, so who will be looking into that whether you are carrying any materials which are not allowed inside the premises and all. So essentially that can be verified at the main gate, right? So that gatekeeper is firewall. So you have a database of signatures. Based on this database of signatures, you identify that this person is malicious, this attack is this packet is malicious, and this packet is legitimate, right? Similarly, like when you are entering in Rashtrapati Bhavan, like gatekeeper acts as a firewall. And then what happens? Suppose you do not carry anything, then you are allowed to enter the Rashtrapati Bhavan premises. Now inside the premise, Rashtrapati Bhavan premise, you can do a lot of malicious act, right? So how that can be identified? So therefore, you can have distributed CCTV cameras placed in different locations, and those locations are basically acting as sensors. Those CCTV cameras are acting as sensors. They basically captures images and videos and basically send it to a particular server, and then server does analysis and identifies, okay, this person is malicious person, this person's behavior is legitimate behavior, and so on. So therefore, you can see that CCTV cameras, distributed CCTV cameras, act as a collective sensors. So they are basically intrusion. It plays like an intrusion detection system. So essentially, what you can have firewall that filters packet based on certain rules, and then once the packet goes through, so at switch level here you can install you can run your intrusion detection system software, right? So you have your intrusion detection system software here that essentially collects data from different network points and then analyzes it, and then it takes action on that, right? So these two together can be a good security mechanism, security solutions to identify intrusions and prevent it, right? So therefore, firewall acts as a first line of defense, and intrusion detection system acts as a second line of defense here, right? And then the second part, so this intrusion detection system plays a huge role here, because you can see that lot of internal attacks, internal intrusions can be actually identified, which is not easy to identify by the intrusion detection. Okay. So therefore, the motivation for machine learning based ideas is that current network environments are very complex and dynamic due to a lot of new attacks which are being launched, and these continuous changes in attack patterns. So therefore, we need to come up with good intrusion detection system that is adaptive to different types of attack, new attacks, that is dynamic. Okay, so the even I say that a particular intrusion detection system I have developed, and that works well in finance enterprise network, but it doesn't work well in academic network or in a utility service network or industrial control network. That should not be the case, right? So it should be dynamic and require least human intervention. So the software should be automated, So involvement of network administrator and others should be very less. Okay, so that is the idea. So if you can see that machine learning is a technique which is which provides computer to learn without explicitly program. So based on the data, it allows the computers to learn, right? So that is the advantage of machine learning. So that can be actually used with anomaly based IDS to come up with ML based intrusion detection system, right? So if we see the traditional programming, there you can there basically you have data and program as input and you get the result as output. But in machine learning, as you know, that we use the result also as one of the input, and output is your machine learning program, right? Your machine learning software. So basically, using data with feedbacks, we need to come up with a very intelligent program that will able to identify any normal any packet, any random packet, whether it is intrusion packet or whether it is legitimate, right? So that is the idea of applying machine learning in intrusion detection system. So anomaly detection, it find novel attacks, identify never seen before attack like zero-day attacks. Similarly, traditional machine learning that learn patterns, identify similar thing. If there are some similar patterns in the data, that could be identified very easily in machine learning. So these two can be therefore merged or combined to come up with a good solution. But it has been observed there are many false positives, right? So that is because of lack of proper training data. If you do not have enough data, right, so you will remain sad. But if you have good data, good training model, then you will be very excited, right? So that is where basically you need to we need to look into that, how we can get a lot of good data where you have legitimate packets information as well as heterogeneous attack packet information. So using those, if we could able to train the software, right, intrusion detection system software, then definitely it will understand it, right? So improper understanding leads to gap between requirements and application. So if your requirements and the applications where you are applying, so if that there is a gap between that, then obviously the solution will not be a fruitful solution. So in that case, you need to establish a bridge between these two. So okay, so you need to reduce the gap between requirements and application. That is an important challenge in machine learning model. So if you see that you need to come up with sound evaluation scheme, getting right features from the data set, getting the right model. That is what we require, right? So I'll not talk about machine learning. So I'll straight away go to one of our applications where basically we use reinforcement learning for intrusion detection system. So if you see, but quickly I'll touch upon, if you see the taxonomy of machine learning. So there are different forms of machine learning, right? Unsupervised learning, where you do not have data labeled, right? You have a lot of data, but these data are not labeled. So in case of supervised learning, you have data set, but the data sets are labeled data, right? So there you therefore your training would be more effective for decision making. Similarly, semi-supervised learning, you have mixed of labeled and unlabeled data. On the other hand, in reinforcement learning, input data is labeled dynamically based on the feedback from the environment, right? So that is what is very well used in today's scenario. Reinforcement learning techniques are well used in dynamic environment, especially, okay, where you need to make dynamic decision making, right? Informations from the environment needs to also taken into consideration, or experience of the environment needs to be taken into consideration. So then reinforcement learning plays a big role. Okay. So there are various models for this under supervised learning, reinforcement learning, unsupervised learning. So I'll skip this. What is reinforcement learning? So reinforcement learning, here you have agents. So agents basically train the a model with the data set, and then it generates some action data, and these data are basically sent to a particular server, let's say server or environment server, where basically which runs close to the environment, and there basically server generates a reward for the actions which are taken by the agent, and those rewards are fed to the agents, and accordingly agents can fine tune their model, machine learning models, training models, right? So this is the idea of reinforcement learning. So we have now we'll go to one of our research in that. So with our students, this work is published in Journal of Information Security in Elsevier, a context-aware robust intrusion detection system. This is also partly published in cyber security conference in Oxford University. So basic idea here is that you divide the whole network into multiple contexts. Okay, so your enterprise network is divided into multiple contexts, and the data is collected from multiple contexts, right? So you can see here, this is one particular segment of the network, this is another segment of the network. So here multiple hosts, they are connected through router, right? So the agent logic is running in these routers, or your in the intrusion detection system softwares, agent program is running in these routers. Okay, similarly here also in this context, there are routers where this agent logic is running. So what this router does, so these routers does I mean, they basically collect the data from the host, and then they train the model. Here they generate, they classify the data, and then they generate state vectors, and these state vectors are basically communicated to the central server, and the central server basically, it is calculating the reward, it calculates the reward based on the environment, and this reward vector is basically sent back to agent. Now based on the reward, agent can actually fine tune its model parameters till the model converges. Okay, so that is what basically the idea is. So essentially you can see here, hosts, all these hosts, they are basically sending network traffic informations to the routers. Agents are these routers. So and then these agents routers, they run the machine learning training here. Okay, and then it generates the action vectors. This is sent to the central IDS. Central IDS calculates the reward, right, with the help of the environment, and then it send it back to the agent. Agent can fine tune the models, it revise the program, right, and till it converges, right. And after that, once this is over, training is over, now testing data can be sent to the agent and to the router, and then router can accurately classify that this is a intrusion packet, and even if it is intrusion, what type of intrusion, whether it is DOS intrusion, whether it is man in the middle intrusion. So all that classifications can be accurately done, right. So this is the idea here. So you can see the workflow here. You have, this is the agent logic which is running in the router. So here you can see that network parameters and host parameters in a given time window is collected from the host, and those are communicated to the router. So router collects all these parameters, then it does feature extractions, pre-processing and feature selection. So feature extraction is basically the attack type. I discussed about based on the data sets, that there are various subclasses which basically defines the features, right. So we extract the features from these network parameters or host parameters, we process it, and then we select some of the important features, and we get the feature vectors, right? So, and then these feature vectors are passed through classifications. So there are classifiers, different types of classifiers are used to generate the classification vector, and then we concatenate this feature vector and classification vector. So we concatenate these two to generate the state vector. Then the state vector is passed to your deep queue network, which is the deep learning models. So it passed through the deep queue network, which has multiple layers, encoders and decoder layers, and then after passing through we get the we do thresholding and on all, and then finally we get the agent result, and this agent result is basically communicated to the central server. This is basically action vector. So this is sent to the central server, and then central server generates reward. So it has again some central server logic. There is a program running here. So it calculates the reward and send it back to the agent. I mean, there is not a single agent, there are multiple agents. So in those multiple agents, then it further updates the deep queue network weights. The network weights, these are updated based on the reward, and further it is re-executed. Okay, and this training is done till convergence, and then after that the testing can be done, right? So this is the agent result calculation. How as I have mentioned, you can see here there are multiple classifiers which we have used. So this feature through these classifiers to get the prediction of the classifiers, the CP1, CP2, CPK, k number of classifiers. Then we concatenate this feature vector and the classification vector. This feature vector and classification vector, this is concatenated into a state vector. This state vector is passed through this deep queue network. Okay, you have input layer, there are deep hidden layers and output layers. Here basically based on the output we are doing thresholding. So after that, so we get the concatenated model prediction result from all these output nodes, and then we get a decision vector. This is of again length k, and this decision vector and this classification vector, they are XORed here. We do XOR operation between this decision vector and classification vector, and we get the action vector, and this action vector is communicated to the central server, okay, for reward calculation. So this is agent logic, and in the once the reward calculation, you can see here for reward calculation, this is the logic which is used actually, and after the reward is calculated, that is basically communicated to the agent for modifying the deep queue network parameters. Okay, so this is the central IDS reward calculation logic. Here basically the environmental informations, inputs from the environment is also taken. Also this can be executed in a sandbox environment, right? So you have a system, right, where you have real informations like what are the different types of attacks which are running in that system, right? So in that environment, central IDS logic can be executed, right? So in the process, the reward calculation will be done more accurately, and it will be communicated, and therefore convergence can be faster, right? So you can see here the reward calculation. After reward calculation, there is a experience replay. So these reward parameters are communicated from the server to this agent. So this is called experience replay, this part, okay, and then further it is executed, re-executed. So this is the idea. So we have done also experimentation. So in the experimentations we have observed, we have used NSLKDD, UNSW, NB15 and AWID, all three data sets with different classifiers like random forest, ADB, GNB, KNN, all these classifiers we have used with varying data sets, and we have observed the accuracy and false positive rate, right? Area under curve also, but we are more interested on accuracy and false positive, right? And it has been observed, you can see that for AWID data set, accuracy is quite high. So therefore, this data set has quite rich information about different types of attacks. That's why this data set, I mean accuracy in the with this data set using different classifiers are in the higher side here, right? So this is one thing, and false positive rates are also reported. However, in the NSLKD data sets, you can see accuracy is not so good, but because this is an old data set, a lot of recent attack informations are not available in those data sets. So based on all these information, first cut results, what we have done is we have, classified the models, the classifiers into high accuracy models and low false positive rate models. Okay. So some of the classifiers giving high accuracy, some of the classifiers giving less false positive rates, right? Right, like GNB, QDA, they are giving low false positive rate, and there are RF, ADB, KNN, they are mostly giving high accuracy, right? For varying data sets, right? So that have been identified. Our observation leads to classify the classifiers into two different buckets: high accuracy classifier and low false positive rate classifier. Then what do? We have done another extended experimentation, another set of extended experimentation. There what we do? We combine these classifiers. We take some of the classifiers from these two buckets, we combine them, and we created classes of such, system of such classifiers. Like we have taken RF, ADB, GNB together to form a class C1, RF, ADB, QDA, C2, and so on. So we have combined different classifiers into a single system, and then we train the model again using NSLKD, UNSW, NB15, and AWI, right? And we have also observed the accuracy and false positive rates, right? And that basically tells you, you can clearly see here that C4 combination is RF, KNN, ADB, and QDA. So this particular combination on AWID data set, it is giving high accuracy and low false positive. So therefore, our observation leads to also a recommendation that for intrusion detection system software, like if you are using AWID dataset, so you can use this combination of classifiers, right, for classification, right? So this is what we have observed. Similarly, for other datasets also, we have seen that which system of classifiers gives better result. And then also we have done analysis on attack wise analysis, like different denial of service attack, fuzers, different types of attacks we have seen. So based on different types of attack, which classifiers give what percentage of accuracy, what is the accuracy for which classifier. So this is based on the data set overall, and this is based on individual attack types. So for example, you can see this is with UNSW NB15 dataset. UNSW NB15 dataset, DOS attack identification accuracy is 92.4, generic is 98.28. Some of the attacks accuracy is less because such data probably the records of such data in the UNSW NB15 datasets are quite less. So because of that, accuracy might be impacted on that, right? Similarly, for other classifiers, we have also observed this. Attack wise, we have observed the accuracy. And then similarly for NSLKDD and AWID dataset also, we have seen NSLKDD, you have DOS, probe, R2L, ATR, this type of attacks. For each of these attacks, what is the accuracy, what is the false positive rate, etc. We have seen across different classifiers. Okay. So and then we have also measured area of curve, which is also looked at for different cases to understand certain things, where you see that our model's area curve is quite higher in the higher side, and that also matching to accuracy, high accuracy and less false positive rates. Then it has been compared with many of the existing modes. So this is our part where we used deep Q network as the double deep Q network as the uh, layers of layered network. So there you can see accuracy is quite high compared to other models. Okay, so AWID dataset, they have also used 95.26, but here we get marginally improve it. But you look at this false positive rate. False positive rate is significantly different. So these are certain observations we have, and then another important thing which I have mentioned, that if you do not select the model appropriately, right, your attacker can actually introduce small perturbation. Let me see. Yeah, so your attacker can actually introduce small perturbation in the data set, and that may bypass the intrusion detection system, right? So what I mean to say is, so suppose I say that if the vector attack vector value is 99, then I say that this is an attack packet. Okay, denial of service attack packet. But what attacker tries to do is that it tries to make it 89.999, right? A small perturbation it introduce in the data, and thereby, so if your model, if it sees that 90%, so that is not close to the perturbation, when the attacker introduced the perturbation, your model could not able to detect that, right? So in the process, it can bypass your intrusion detection system, right? So therefore, what we have done after that, we have also introduced injected various types of attack, right? So DOS attack we have created man in the middle attack, we have created these attacks, and then in such adversarial environment we tested our system. So there what we did, we have generated adversarial data for training. So what is adversarial data? You have a test data, and then you have labeling on this test data. Then we have used some statistical analysis models like JSMA model, in this case Jacobian based saliency map attack. So by doing that, so we generated adversarial data, some modified data from the test data. We have generated modified data with small perturbation, and those data we use for training as well. Those data we have used for training the model as well, right? So and that also improves the performance of our system, right, in presence of adversaries, that have been also looked at. So for adversarial attacks, we have used, after generating this adversarial data, we have used this denoising autoencoder for training. So this is a simple encoding and decoding logic with less number of layers. So this is used for training the model on top of our normal deep Q network, right? So after that, we have tested and we have seen this result. Model before adversarial attack, your accuracy was 81.8% and false positive rate was 2.6%. And then when we injected adversarial attacks, then accuracy falls down. Accuracy comes to 78.44, and false positive rate also it increases. But then after that, when we use denoising autoencoder, then it further improves. So in adversarial environment, also the accuracy is quite higher. This is with NSL KDD. Similar experiments have been done in, with the UNSW NV15 and AWID data sets, and we have observed the result, and we see that it is really in higher side. Accuracy and false positive rate really is in higher side for our model compared to the other paper which has used this reinforcement learning. Okay, so this is one work. The similar kind of approach we have used for cloud in cloud computing platform, right? In cloud computing platform, what happens in a host network, right? There are multiple hosts. They are running multiple virtual machines on top of a hypervisor, right? So these virtual machines basically runs various applications, network applications, right? So is there any vulnerability? Is there any attack while these virtual machines are running, right, in the host network? That also can be identified. So we have done experiments in such environment, right? So there, what we have done is we have multiple hosts, and we have a number of virtual machines running for different network applications. And what we have done is we have taken the state informations of the running virtual machines. So the running state informations of the virtual machines, like what are the softwares which are running, what is the CPU utilization, what is the memory state, the program variables, right? All those information, state informations have been taken from multiple virtual machines, and those are passed through VPN, the secure gateway. Through the secure gateway, it is passed through the router agent network, right? And then there again same analysis is done, like log generation, VM, structured log generator, agentic queue network. Similar logic we have used here, and then it has been sent to administration network for reward calculation, and further modification is done in the agent network. And there also we have used this like idea, and we have identified novel attacks, okay, which are specific to cloud platform. Like there are in hypervisor, we have observed there is a service called virtual machine migration. So in virtual machine migration, what happens? So from one machine, the running applications are migrated to another machine, right? So in this case, basically the state information of the source virtual machine has to be completely copied to the destination virtual machine, and once this is done, then source virtual machine can be halted, stopped, and the applications will be run in the target virtual machine, right? So in this migration service, we have seen many software, many platforms, like Jane platform we have mainly see, and another like Oracle Hyper-V. So these two platforms, like hypervisor platform, we have seen that this virtual machine migration process is actually malicious. So there are some programs, right? There are some programs which are actually not doing end of string uh, checks are not there. Because of that, there are buffer overflow, and unauthorized user, they can access to memory segment of virtual machine, and thereby get sensitive information. So that is basically identified in this, right? In case of virtual machine migration, the whole state informations are migrated through network to the destination machine, and then the target machine is made up. So and this is not happening in one iteration; it happens over multiple iterations. So first some portions of the memory state informations are migrated. Then while the source machine is running, some memory state information might be changed later, right? Then only the changed memory part is actually migrated further in the destination machine, and this happens over the iteration while source machine is in execution. So source machine is running, during that time the migration is taking place. We call it as live migration. So this live migration time, there are vulnerabilities that has been observed and that have been basically identified here, right? So this experimentation also have been compared with another paper that is published by University of Michigan, and we have compared with that, and we have published in University of Oxford Cybersecurity Conference. Okay, so this is one such work, and then this is another work where basically we have used machine learning for malware detection in host, in a single host, right? So what we did here is that we have used open source malware analysis tool that is called Cuckoo Sandbox. So this Cuckoo Sandbox is used as the malware analysis tool. So what we have, what this Cuckoo Sandbox does, it takes suspicious files, right, and then it generates a detailed report, okay, of the running behavior of that file in the corresponding system as executed inside. So the detailed report of that particular file running in the system, that is generated by this Cuckoo Sandbox. So we have used this open source platform for malware detection, intelligent malware detection using machine learning. So what we have done is we have initialized, we have taken some random sample files, okay, and then we pass it to Cuckoo Sandbox, and then Cuckoo Sandbox gives us a detailed report for these sample files. Then from there we have extracted features, some relevant features we have selected from there, and then in the process those selected features we group it into micro and macro data sets, okay, and some of the data sets which are write more fine-grained informations about the subclasses of malware files. So those informations are actually kept into micro data sets. Otherwise, high-level descriptions are kept into macro data sets. So this is basically to reduce the complexity, right? If we run the machine learning model with macro data sets, probably it takes lesser time. However, if you use micro data set, it takes little higher time. Again, depending on the context. So use both of them, right? And these features are classified, divided into training data set as well as testing data set. So some data sets are, some features are used for training. Similarly, some are used for testing purpose. I mean, some data sets. And then we basically use different classifiers, binary classifier as well as multi-class classifier. So binary classifiers, they are basically just saying that whether it is malware or not. And in case of multi-class classifier, we are also taking into the classes of the malware, right? The what type of malware it is. So this is done. We train the machine learning using this machine learning model, and then after that we test it with random data set, and which are right, which may contain what I mean to say, which may contain malware data as well as non-malware data, right? So randomly those data are pushed into, and basically it gives you that whether it is malware or not, right? So this is one work we have done, and we have seen that here decision tree classifier is giving higher accuracy, uh, so therefore, so this is and also different classes of malwares we have taken, like virus, adware, trojan, spyware. So different types of malwares we have taken, and we have used machine learning models to detect those malwares, right? So I think with this, I will conclude here. Today we talked about uh, what are the cyber security challenge in today's scenario. Large volume of data is getting generated, and those are communicated or those are stored remotely. So in such cases, obviously cyber security, maintaining security for those platform or those data is obvious challenge. And if we see, there are various cyber physical system environment like industrial control, energy, right, healthcare, many cases. So this is a crucial challenge to maintain security as well as privacy. So and then we talked about that what are the different footprints of cyber attacks, like in computing platform, in network infrastructure, in web services, right? And then we talked about different types of intrusions in terms of models, in terms of deployment environment, whether it is online or offline, right? Whether it is centralized or distributed. Then we discussed about different solutions like firewall, intrusion detection system, and we talked about intrusion detection system, especially anomaly based intrusion detection system, which is quite well used today. And then we discussed how machine learning can be used for intrusion detection with higher accuracy and low false positive rate. Then we discussed one of our result. Similar techniques can be also used in cloud platforms and also for malware analysis. So with this, I think I'll stop here. So if you have any questions, I'll be happy to yeah, respond. Thank you very much.
Thank you very much, sir. Any question? Any question from the participant side? Any question? Yes, sir. Is it any question is printed on the written on the chat box? Yes, sir.
Okay, so there are some questions, right? Is there any question in the chat box? Nicely explained. Please share slide. Yes.
Yes, sir. One question from Shomik Bhattacharya. Am I
Okay.
audible to you, sir?
Yes. Yes.
Yes,
Yes.
one
Please.
question from Shomik Bhattacharya. Can we say attacks happen inside and outside of DMZ? I think DMZ means demilitarized zone network. Can we say attacks happen inside and outside of DMZ?
Uh, it can happen. See, demilitarized zone, they are basically you, again, it is done based on certain informations, right? You do not randomly create demilitarized zone. You create demilitarized zone with some specific system. Now, depending on the context, depending on the application environment, if you consider completely, restricted environment, so there definitely chances of attacks inside the demilitarized zone, so that may be different. However, attack may happen in both cases, right? For example, if I take banking network and if I take academic network, the context would be completely different. So how you create your demilitarized zone, based on that it varies. Yeah, but it happens in both cases. Am I clear? I mean, could I give the correct response to the question, or you know, is it okay? Samik Bhattacharya said thank you. Yeah, I think this is clear. Any more questions?
Sir, I have a very basic question. Am I audible? Yes.
Yes, yes.
I have a very basic question that the malware and spam and all these software worms and different worms and all whatever you have discussed, as well as hardware related security issues. Sir,
Mhm.
as much as different techniques and strategies have been invented to protect it, and day by day new kind of new varieties of issues are also arising. Nowadays, if I see on the web, millions of fake news and audio, video, whom to believe, whom not to. So there are so many protection protocols are also there, but the varieties are also increasing. So how to, what is your observation? What is the conclusion on it? What is your observation on it?
Right, right. So it is really a good question. So obviously, if we see the type of like malwares and different types of intrusions which are being introduced, they are enormous, and they are really heterogeneous in nature also, right? So and it is because of use of softwares which are really not, security graded softwares, right? They are not like stamped with that these are cyber security compliant software, right? And we are very often using open source softwares which are not cyber security compliant, right? So because of that, obviously we cannot control that. We cannot control uses of those softwares. Obviously, like in restricted environment like banking, energy, smart grid, so they are not using open source software. They are definitely using certain softwares in a which are like more reliable softwares. But even then also, because the misconfigurations at the device levels, those are also introducing new attack paths. So the type of network attacks which are actually varying, right? Which we can which we can say that which we cannot control. So therefore research has to be done. Research has to be done. What I mean to say, that when today you see that a lot of files are there which are malicious in the internet, can we use those informations to create new data sets, and those data sets can be used for further training to come up with good solutions? Or can we that can help in coming up with new standards, that can help in coming up with new standards, that okay, if this type of if X is there, then we say that this is attack. If Y is there, this is attack, something like that. If we can have such kind of standards, that the standards can be built based on this analysis, right? So I think it is a valid question, uh, but at the same time, efforts from different end are happening to make it make it more and more secure, make the environment more and
In
more
fact, hundreds of articles and conference papers, journals are available on fake news detection. Recently, Jadavpur University is
yes,
working
yes,
very
yes,
well in this domain on fake news detection. But if we, switch on our mobile, among 100 newses, we will get 50 are valid and 50 fake. Then I don't know that all these research and articles and algorithms, modules which are being developed day by day, how, I mean, I don't know how and to which direction we are proceeding, that we do not restrict too much. Sometimes it becomes impossible to distinguish which message is correct and which one is not. Okay, sir. Thank you very much. Thank you.
right.
Sir, am I audible to you? PLB
Yes,
sir, am I audible to you?
yes,
Yes,
Siddharth.
sir, thank you for your session, sir. You have nicely explained each and everything here. So I have a small question. From 2022, we have all learned about zero-click vulnerability, Pegasus, etc.
Hmm.
So till now, there is no any mitigation approach basically.
For
I
for
want to know.
for Pegasus, there are work there are certain data sets. You can see new data sets which are there. That is iShot CID data set, right? So that you can check in the internet. So this data set actually takes subclasses of Pegasus attack.
Okay, okay,
Yeah. There are some research in that.
okay,
Okay.
sir. Okay, thank you, sir.
Okay, then we should come to the conclusion now. James, sir.
Okay. Thank you, Dr. Bera, for your wonderful presentation. Sir, your expertise and knowledge have certainly enriched our understanding. We're really grateful to Dr. Bera for the time, effort, and dedication he has devoted to make this session both informative and inspiring. Now, as a mark of respect, we would like to present a certificate of appreciation to Dr. Bera. Kaushik sir, please. Sir, please accept it.
Yeah, I accept it. Thank you very much. Accept the certificate. Thank you very much for inviting me, and I thank all the participants for joining.
Thank you, sir. Thank you. Thank you, sir. Okay. Okay. Thank you, sir.
Okay. So thank you very much. So if you have any queries, please reach out to me. I think my email ID is available with the organizers.
Yes.
So for any further queries or any research in this direction, so please be in touch. Thank you very much. So I'll close it now.
Yes, sir. Yes.
Yeah.
Thank you,
Bye.
sir. Thank you
Thank
very
you.
much.
Now I request our HOD sir to start the valedictory session. Sir, please.
Okay. Thank you, sir. Thank you, James, sir. Without any time delay, let us conclude this 5-day session. First of all, thank you everyone, all the respected participants, and from throughout the India and also outside India, all who have participated in this event. Thank you all. And officially and formally, I am a coordinator of this event and I am an HOD of this department, but I am a part of this event. So this event has been organized by the Department of CSE, and the motto of this organizing this event was, you see, from my personal experience, I can say when we face our students in UG level, PG level, or PhD students, then we face the first problem we face. This is finding a proper problem definition. That is the first challenge. In which domain we will try to proceed. This is the main motto of organizing this event, and we have invited the speakers from different sectors, from IITs to ISI to different industry, different research sectors. We have invited just to be familiarized with miscellaneous types of problem definitions, as we can use it in our future. So how much effective it became, that time will say, and it varies person to person. But we have tried our best. All the faculties and staff of the CSE department, Kulaghat Engineering College, we have tried our best to conduct this event as smooth as possible. Finally, last word I will say, feedback, attendance, test, certificate, all these are the part of this event, formality of this event. We have to carry out those things also. But above all, enjoy learning. It is the ultimate thing. Thank you very much. I hope we will see you all again in our coming events. Thank you. Now, sir, we are requesting our respected participants, those who have participated in this event with immense patience, and they have they remained with us from first to last with during all the sessions with patience. Sir, we request you you all, if any one of you wants to say anything to us, then we will be happy. Sir, anyone, sir, madam, anyone, if you want to share your experience or your suggestion or opinion with us, then we will be happy. Sir, ma'am, respected participants, please. Anyone from the participant side, ma'am, sir, if anyone wants to share your experience during last couple of days, in your any suggestion or opinion, your experience. It will be asset to us. Thank you, sir, ma'am. If you share anything with us. Okay, sir, is any sir and madam tries to unmute himself or herself? Is it possible? Okay, sir. I think yes.
Hello. Participants can unmute themselves.
Okay. Any sir or madam, if anyone wants to say anything, kindly unmute yourself and you share your views or comment or anything with us. In the chat box, we have seen so many appreciations. Thank you very much. But still, if you want to say anything, kindly unmute yourself and say a few words. And even if anything is wrong with us, if you want to give any suggestion to rectify, definitely you can point out that thing. Okay. Umesh sir, Dr. Umesh Kumar, yes sir.
Yeah, Dr. Umesh Kumar, I am speaking here from Jharkhand, you can say. We have attended your program
Yes.
and the program was very nice. And in fact, I can say that intelligent computing technologies and engineering applications is a very relevant field. And these days, everyone should have such inputs and knowledges about these fields. And this program, whatever you have covered, the topics you have covered, was very, very relevant. And it is much needed and useful for at least I can say for all the technical persons. So we are really very thankful to you and to your all esteemed guest lectures. We were benefited and we were benefited immensely. Thank you. Thank you for conducting such program.
Thank you, sir. Thank you very much. Thank you very much. Any other sir or madam, if you wants to say anything? Our director sir, sir, are you online? Director sir, are you online? Director sir.
I think Director Sir not joined till now. I've informed Director Sir.
I already joined.
Okay. Yes, sir. Yes, sir. So now our respected director, sir, actually, sir was busy in a meeting. That's why we requested, sir, if it is possible, just make few minutes for us. Sir, our session has been completed and our respected participants are still there with us in this valedictory session. So if you just share a few words about this event and any note from our college also. Okay, sir. Thank you.
Thank you, Alok sir, for introducing me. Good evening to all the distinguished guests, eminent speaker, faculty member, and participants. As we complete this one-week faculty development program on intelligent computing techniques and its engineering applications, I am filled with immense gratitude and pride for the journey we have undertaken together. This program has been an indication of the spirit of collaborations, learning, innovations that drives our institutions and our community of educators and learners. Over the past week, we have had the privilege of hearing from some of the brightest minds in the field of distinguished academicians and industry leaders who have shared their insight and expertise. Through their lectures, workshops, and interactive sessions involving technological landscape, it was provided a platform for meaningful discussions, exchange of ideas, the forging of collaborations that will undoubtedly have a lasting impact on our professional and academic endeavors. I extend my deepest gratitude to all the speakers for their enlightening contributions, to the participants for their active engagement, and to the organizing team for their tireless effort in making this program a success. Special thanks to Dr. Alakranjan Pal, HOD, Department of Computer Science and Engineering, and the program coordinator and the convener for their dedication and meticulous planning. As we part way, I ask each of you to carry forward the knowledge and inspirations gained during this program. Let us strive to implement this insight in our teaching, research, and professional practices, contributing to the advancement of intelligent computing and its application in engineering. Thanks you once again for being a part of this program. Wishing you all continued success in your academic and professional pursuit. Have a safe and pleasant journey. Thank you. Thank you all.
Thank you, respected Director Sir, for joining us. Now, we are very last point of this event. Now, if any sir or madam, still our convener sir just mentioned that you request them once again, if any one of them wants to say anything, you once again, that's why I'm requesting you all once again, if you want to say anything, kindly share. Otherwise, our convener share, we will take the vote of thanks to conclude the event. Thank you, sir and madam. If any one of you wants to say anything, you may share. Okay. Thank you, sir. Okay, we have got so many messages on the chat box also. It's okay. We are very happy. Now our okay. Bharati ma'am.
Hello.
Bharati ma'am. Okay, ma'am. Okay, ma'am. Please.
Very good evening, everyone. I'm very happy to share my thoughts that the FDP was very nice, excellent, the way of organization and all these resource persons, whatever they have shared, it is helpful for us for going ahead with the research related things as well as in academics. Only thing is that due to the busy schedule of academics, some of the sessions in between I couldn't do attend. So my request is, if possible, share the details related to the PPTs and some of the things which will be shared through Google Drive, and link will be shared. That will be helpful for us for go ahead for research work as well as certain subjects which are related to these things. So this is my kind request for the organizers, and it was really excellent. I had tried to attend now all the sessions, but in between I had certain lectures as well as practical schedules. So some of the sessions I missed in between. So that is the thing I request. So thank you so much. I'm happy to be part of this group, and I'm looking forward for such kind of the things in future as well. Thank you.
Thank you, ma'am. Actually, our university examination is also going on at this moment. So we all are in the same boat. Okay. Thank you. Thank you. Okay, now our finally our convener sir, Dr. Tapas Kumar Maiti sir, will take the vote of thanks, and sir will conclude the event. Thank you. PKM sir.
Hello. Hello.
You are audible, sir. You are audible, sir. Yes, sir.
Okay. Respected honorable speakers, director, HOD, esteemed colleagues, and dear participants, a very good evening to everyone listening to me. It gives me immense pleasure to deliver the vote of thanks on behalf of the organizing committee. As we come to the conclusion of this enriching faculty development program, I feel honored to express our gratitude to all those who contributed to making this event a success. First and foremost, I would like to express our sincere thanks to our eminent speakers and resource persons who have taken time from their busy schedules to guide us. Dr. Debabrata Samanta, Dr. Urbi Chatterjee, Dr. Shagatam Das, Dr. Siporna Saha, Dr. Soumodip Bandyopadhyay, Dr. Catherine Kind Treller, Dr. Sandeep Kumar Shukla, Dr. Debanjan Konar, Dr. Debashis De, and Dr. Padmalochan Bera. I again pay my thanks all these eminent speakers. Their expertise, knowledge, and thoughtful, provoking sessions have enriched our understanding and have given us a new perspective on teaching, learning, and research. Their words of wisdom and encouragement have inspired us all and will certainly motivate us in our professional journey. I thank to Professor Lipika Datta for smoothly conducting consecutive 3 sessions, session 1, 2, and 3. I am thankful to Professor Alok Ranjan Pal, who is also the coordinator of this event, for conducting sessions, session 4, session 7, 8, and 9. My sincere thanks to Professor Joydev Mishra, who conducted the 6th and last session today. I also put my sincere thanks to Professor Soumitra De, Professor Siddhartha Chatterjee, and Professor Abhinava Bhattacharjee for joyful conduction of the sessions. My special and sincere thanks and gratitude to Professor Kaushik Sinha for his total dedication, who work hard as the backbone for the entire technical support, starting from brochure design, web support, continuous monitoring of the sessions, and posting comments and links in the chat box time to time. I must thank to Professor Siddhartha Chatterjee and Head of the Department Computer Science and Engineering, who have jointly done a rigorous job of selecting and continuously communicating the eminent speakers and resource persons of the FDP. I also offer my thanks to my beloved daughter Trijita Maiti Raka, who composed and edited the Saraswati Vandana played on first day during the inauguration session. I would also like to extend our sincere appreciation to all the participants who actively engaged in the sessions. Their curiosity, enthusiasm, and willingness to learn have been the driving force behind the success of this program. It is their participation that made this FDP truly meaningful. A special thanks to the organizing committee, faculty and staff members, volunteers, and all those behind the scenes who work tirelessly to ensure smooth conduct of this program. Their efforts are deeply appreciated, and this event would not have been possible without their dedication. Finally, I would like to extend my heartfelt thanks to our institution and the management for their unwavering support and encouragement. Their continuous commitment to professional development initiatives like this one enables us to grow and thrive in our academic careers. Once again, thank you to everyone for being a part of this wonderful FDP. I hope that the knowledge gained here will inspire us to implement new strategies, improve our teaching practices, and further contribute to the field of education. Wishing all the best in the future endeavors. Have a great day. Have a great day ahead. I finally now conclude the 5 days FDP. Thank you all.